This is Scholar Staff doing some math. Today in geometry, we're looking at proving triangles congruent by ASA and AAS. So, in the beginning, we started by showing that all corresponding angles and all corresponding sides were congruent in order to show that two triangles are congruent. Then we learned SSS, SAS, and HL. Now we're going to learn two more things, ASA and AAS. ASA is angle side angle. And let's try to draw two triangles here. And let's imagine that these two triangles are congruent. So A, B, C, D, E, F. So if this angle was congruent to this angle, and this angle here was congruent to that angle, and then the side in between the two angles were congruent, then these two triangles are congruent. So if two angles and the included side, or the side in between, are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So triangle ABC is congruent to triangle TEF. Okay, and then there's angle, side. I, J, K, L, M, N. So let's have these two angles. The same. And then this side. So two angles and a non-included side. So it works either way, two angles and the side in between, or two angles and a corresponding side. That'll show that triangle JK or IJK is congruent to LMN. So what do all postulates and theorems about triangle congruency have in common? You must have at least one set of congruent side. You must have at least one set of congruent sides. So there is no AAA, sadly. No AAA postulate. And let me show you why there is no AAA. Let's say we have a big triangle. And let's say that these are all 60 degrees. And then we have an itty bitty triangle. But everything's still 60. So you can have all the angles be the same, but the triangles don't have to be the same. So can you prove that these triangles are congruent? Why or why not? Part A. So we have two angles, and then we have this angle here. So we have AAA. No. That's all we have. We need at least one set of sides being congruent. So part B, we have this side being the same. So this would be angle, side. Part C, We have this angle in the middle here. Because those are vertical angles. So we have angle, side, angle. See how we have two angles and then the side in between. So yes, yes, A is no. Part 1, can you prove that triangle STW, okay, STW, okay, is congruent to VWT. So the big left triangle is congruent to the right triangle, because there's enough information. So sometimes you have to redraw your picture. So here's STW. And then we have VTW or VWT or VWT. And we know that they both have right angles. And we know that's 60 degrees here. Okay. So notice, and sometimes it's easier to just keep the picture how it is. So notice, let me draw the other triangle in blue. Please. There it is. So notice that they both share the bottom side. So that side is congruent to that side. That means we have angle, angle, side. We have two angles, and the side that's not included. Okay, part B, let's see what we got. Okay, left triangle, right triangle. So they both share this side, and it looks like we have angle, side, angle. We have two angles that are congruent to each other and the side in between. Alright. Now let's look at this flow proof stuff. So flow proof is different from our normal proofs, but it can it might help you visually do the traditional proofs. But let's go through this one to show you how it works. So usually it's still the same, given and prove. So they have a picture here. And what you want to do is you want to first put all your given down. So they put angle 1 is congruent to angle 4, and they put that down. So this was given, and this was given. Okay. So you put your statements in boxes, and then your reasons right under it. Okay, and then I'll explain the arrows in a second. So they're claiming that there's something else from the picture that we can take. And it's the fact that angle 1 and angle 2 are supplementary. And so is angles 3 and 4. Supplementary. Sorry, that's a little messy there. Supplementary. But anyways, let's look at 1 and 2 and 3 and 4. So notice that angle 1 plus angle 2 adds up to a straight line. That means they're supplementary. Supplementary means they add to 180. Okay, this is definition of linear pair angles. Or supplementary angles. Yeah, I'm just going to say supplementary angles. Okay. So now we put all our given out. And what we're supposed to draw upon is we're supposed to use our given, and it should lead us somewhere. So for example, let's look at the right here. CF bisects angle ACE. So what does that mean? That means, so ACE, where's ACE? I'm going to assume that this is A. So ACE, so they're talking about this big angle here. And the line CF bisects it, which means it cuts it in half. That means angle ACF is congruent to ECF. And that's because it's the definition of the angle bisector. Definition of angle bisector says if something bisects an angle, then it splits it into two congruent angles. Okay, and then they draw the arrow because this statement leads to this next one. Okay, CF bisects angle ACE. So that statement leads to the two angles being congruent. Okay. Sorry. And then so now let's look at the left. They tell us that angle 1 is congruent to angle 4. Angle 1 and angle 2 are supplementary. Angle 3 and angle 4 are supplementary. That means angle 2 is congruent to angle 3 by the congruent supplement theorem. If you don't remember what that is, the congruent supplement theorem says if two angles are supplementary to the same angle, and since angle 1 and angle 4 are the same, then those two angles are also the same, angles 2 and 3. Angles 2 and 3 are both supplementary to 1 or 4. Since 1 and 4 are the same, 2 and 3 have to be the same. And then they wanted to show that this is supposed to be a triangle. There we go. So we're trying to show that those two triangles are congruent, CBF. So this upper left one and then the upper right. Okay. Since we showed that angles 2 and 3 are the same, and we have those upper angles being the same, we just need at least one side. And they chose CF. CF is congruent to itself because of the reflexive property. And now that we have two angles and a side, we can prove that the two triangles are congruent. Now, if you like this way, you can go this route, but you're mostly going to be tested on the traditional route. There might be a few of these, but it's most likely going to be the traditional proof writing. Alright, let's do the next problem. Actually, I might skip these, but basically, yeah, I'll do one. So two actors stand 20 feet apart on the stage in the theater. So here's actor 1, actor 2. And they have a spotlight. So there's two spotlights that are angled at 40 degrees from each other. So we got spotlight 1 on one actor and spotlight 2 on the other actor. Can one actor move without requiring the spotlight to move and without changing distance from the other actor? So this is a no. One actor cannot move without entering a spotlight, without either moving a spotlight and without changing distance from the other actor. Sorry. Basically, what's going on is, let's say the actor moves backwards. Well, if he's not, the his spotlight definitely has to move that way. So you'll get, I mean, it's kind of obvious when you look at it. If one actor moves, like let's say he moves that way, that means the spotlight has to move that way as well, increasing its angle. So no, it's just what they try to do with this problem is that they're trying to show you that it's like, no, you're going to make a different triangle if he moves over here, because this will no longer be 20 feet, it will be longer than 20 feet. If you were able to show that the triangles were congruent, like whether using any of our angle side angle or angle angle side or any of those other congruence theorems, then you can say yes. But the triangles, the new triangles that would be made, let's say he moved here, for example, this would be a different angle for sure, and the other actor has to move with actor if they want to keep 20 feet apart. So no. This top upper example talks about they're in the woods, and they know that they're 75 feet apart, and for some reason they know that they're 72 degrees in that direction is the flag, and 53 degrees in the flag, and they're asking whether or not, if there's enough information. Yeah, there is enough information. You just travel in that direction and you'll probably see the flag. So that's that. Let's move on. Have a good day.